Sometime today, probably without thinking, you flipped a switch and a light came on. First the switch, then the light. It is the one rule the universe has never broken for you. Not once in your entire life. Causes come first, effects follow. Nothing feels more certain than that. So here is something strange. Physicists have searched the fundamental laws of nature for that rule for more than a century, and it is not there. It is missing from the equations of motion, missing from the mathematics of light, missing even from quantum theory itself. Every one of them runs just as happily backward as forward. And this spring, a team of physicists published something that was long believed to be impossible, a possible origin for quantum physics, built from a deeper level of reality where cause and effect do not exist at all, a place with no before, no after, nothing that happens first. If they are right, the most basic rule of your existence was not written into the universe. It was manufactured. So who or what taught the world to put causes before effects? Get cozy tonight. Subscribe if you have not and stick around, because by the end of tonight you will know exactly what these physicists discovered, what it cost them, and whether it truly changes everything. Let's get into it. Part 1. The rule nobody wrote. There is a law of nature you have never once seen broken. It is not gravity. Astronauts float free of gravity every day, and we cheer them on. It is not the speed of light, which most of us will never get close enough to test. It is something so common, so woven into every second of your existence, that it has never needed a famous name. Causes come before effects. You flip a switch, and the light comes on. In that order. Always in that order. Think about how much of your life quietly leans on that one rule. You set an alarm at night because you trust that the setting will come before the ringing. You plant a seed in the spring because the planting comes before the harvest. You apologize to someone you love because the words spoken now can shape what happens next. And never, ever the other way around. Every engine that has ever turned, every court of law that has ever weighed a verdict, every doctor who has ever traced a symptom back to its source, all of them are built on the same silent foundation. First this, then that. The switch, then the light. Anyone who has spent time around small children knows the rule has a sense of humour about it. In a house with a toddler, the effect simply happens. The vase is on the floor, the cat is wearing yogurt, and the cause firmly denies all involvement. But even that joke only works because the rule is so absolute. We laugh precisely because we know, with complete certainty, that somewhere in the recent past there was a cause, and that it came first. The universe does not deliver shattered vases from nowhere. It never has. Here is where tonight's story begins, and I want to give it to you plainly, because it is one of the strangest confessions in all of science. Physics, the discipline that measures the wobble of stars from millions of light years away, the discipline that predicted the bending of starlight before anyone had seen it happen, cannot find that rule anywhere in its fundamental equations. The most obeyed law in your life is written down nowhere in the underlying grammar of the universe. Let me show you what I mean, because it sounds impossible the first time you hear it. Take Isaac Newton's laws of motion, the physics of planets and cannonballs and falling apples. Imagine filming the solar system for 1,000 years, every orbit, every moon, every slow gravitational waltz, and then playing the film backward. Here is the uncomfortable truth. The backward film breaks no laws. Every planet in the reversed film still obeys Newton perfectly. Nothing in the equations blushes, nothing objects. If you handed both films to a physicist and asked which one shows the real universe, Newton's laws alone could not tell them. The same is true of the equations that came after. James Clerk Maxwell's equations, which govern light and electricity, and every radio wave passing through your body right now, run just as happily backward as forward. Erwin Schrödinger's equation, the beating heart of quantum mechanics, the mathematics that describes atoms and molecules, and the glow of every screen you own, time-symmetric, top to bottom. Even Albert Einstein's field equations, the ones that describe gravity as the curving of space and time itself, have no arrow drawn on them. In every one of these theories, a process running one way and the same process running the other way are equally legal. The universe's rulebook, read cover to cover, never says which direction the game is played. And yet, you have never seen a cold cup of coffee gather warmth out of the tabletop and begin to steam. You have never seen a shattered vase leap from the floor into a toddler's innocent hands and reassemble on the shelf. You have never, not once, seen the light come on before the switch was flipped. The rule that governs everything is missing from the rulebook that governs everything. Sit with that for a moment, because the entire night ahead of us lives inside that gap. Now, I want to be careful here, because some of you have travelled with this channel before, and you may be thinking of other nights we have spent inside the mystery of time. We have explored in the past why time seems to flow, and how the direction of that flow is tangled up with disorder, with entropy, with the universe's tendency to move from tidy toward messy. That is a real and beautiful story, but I want to be clear that it is not tonight's story. The entropy story explains why some processes are hard to reverse, why scrambled eggs stay scrambled. It gives time's river a current, but it quietly assumes there is already a riverbed. It assumes there is already such a thing as before and after, an ordering of events, a stage on which earlier and later make sense. Tonight we're going one level down, beneath the current, to the riverbed itself. Tonight's question is not why time flows in one direction. Tonight's question is where the ordering of events comes from at all. Why is there a before? Why is there an after? Who or what decided that events line up in a sequence, with causes on one side and effects on the other? For most of the history of physics, that question was treated the way you might treat a question about why there is something rather than nothing. A fine thing to wonder about over a late drink, but not the sort of thing a working scientist could touch. The ordering of events was simply the stage. You do not ask where the stage comes from. You perform on it. But this spring, in a peer-reviewed physics journal, 2 theoretical physicists published a paper claiming something remarkable, that the stage can be built, that the ordering of events, the very existence of cause and effect, can be derived step by mathematical step from a deeper theory in which order does not exist at all, a theory with no before, a theory with no after, a theory in which events simply are, unarranged, like a box of photographs with no album to hold them in sequence. And out of that orderless deep, through a process with a strange and wonderful name, our entire familiar physics, quantum mechanics itself, with its causes and effects intact, condenses like dew. Here is what makes that claim more than just another interesting idea. It was supposed to be impossible. Not impossible in the loose, conversational sense. Impossible in the mathematical sense. There is a theorem, published by serious researchers and cited for years, that was widely read as proving no deeper theory could ever hand quantum mechanics up to us this way. The door these 2 physicists walked through was a door the field had marked, in writing, as permanently sealed. And they did not break it down. They noticed something about the hinges. So that is the question I am holding up for tonight, and I will make you the same promise this channel always makes. By the end of our time together, you will know exactly what these physicists discovered about the origin of quantum physics. You will know what they built, what it cost them to build it, what the sharpest critics said about it, and in precisely what sense it changes everything, and in what sense it does not. I am not going to hand you the answer now. The answer only means something once you have felt the size of the question, and the question is enormous. It has been growing, quietly, for more than a century, fed by some of the most brilliant and most frustrated minds in the history of science. Because before anyone could dream of deriving cause and effect from something deeper, physicists first had to notice that cause and effect was missing from their equations, and then they had to go looking for it. They searched the mechanics of Newton, they searched the light of Maxwell, they searched the curved space-time of Einstein, and there, for one hopeful moment, they thought they had finally found where the universe keeps its order. What they actually found was stranger. They found that the hiding place itself was hiding something. That search, 100 years of increasingly desperate cleverness, featuring a philosopher with a grudge, radio waves that arrive from the future, and a map of the universe drawn entirely out of influence, is where we begin. Because you cannot appreciate how shocking it is to find the origin of causality until you have watched the smartest people who ever lived fail, again and again, to find causality itself. So get comfortable, let your eyes rest, and come back with me to the year 1913, to a philosopher in Cambridge with a talent for demolition, who stood up and said the quiet part out loud, that the law of cause and effect, the most sacred rule in science, might not be a law of nature at all. Part 2. The physicists who went looking for causality. The suspicion that something was wrong with causality is older than physics itself. In the 1700s, the Scottish philosopher David Hume made an observation so simple and so corrosive that philosophy has never fully recovered from it. "Watch one billiard ball strike another," he said. "What do you actually see? You see the first ball move, you see the balls touch, you see the second ball move. What you never see, what no one has ever seen, is the causing. You do not observe some thread of necessity running from the first ball to the second. You observe one thing and then another thing in sequence, over and over, until your mind stitches the sequence into a story. Causation," Hume argued, "might not be something in the world at all. It might be a habit of expectation, worn smooth into the mind the way a path is worn into grass. We feel the connection because we have walked it 10,000 times. For more than a century that remained a philosopher's worry, clever, unsettling, and easy for working scientists to ignore. Then, in 1913, the philosopher and mathematician Bertrand Russell decided to stop being polite about it. Russell had helped rebuild the foundations of mathematics from the ground up, so he knew what a rigorous law looked like, and when he went searching through the physics of his day for the famous law of cause and effect, he found something scandalous. It was not there. The equations traded in functions and relations, in quantities determining other quantities. But the grand principle of causality, the sacred rule that every event must have a cause that precedes it, appeared in none of the actual mathematics. His verdict has been quoted by physicists ever since, usually with a nervous laugh. The law of causality, Russell wrote, is a relic of a bygone age, surviving like the monarchy, only because it is erroneously supposed to do no harm. Notice what Russell was not saying. He was not saying that the world is lawless, or that anything can happen at any time. He was saying that when you look closely at the fundamental laws, the ones that actually earn their keep by making predictions, the notion of cause and effect dissolves into something else, into patterns, into regularities, into mathematics that runs equally well in either direction. And the century of physics that followed him made that observation sharper, not softer. Consider the strange case of the radio wave. Maxwell's equations, the complete description of electricity, magnetism, and light, are perfectly symmetric in time, and that symmetry has a bizarre consequence that engineers simply learn to live with. When you solve those equations for a radio antenna, the mathematics hands you two families of solutions. One family describes what you would expect: waves rippling outward from the antenna, spreading into the future, carrying the evening news to distant receivers. Physicists call these the retarded solutions. But the second family is just as valid on paper, and it describes something no one has ever witnessed: waves converging inward from the distant universe, arriving from the future, collapsing onto the antenna at precisely the moment of transmission. The advanced solutions, they are called. Nature, as far as anyone can tell, uses only the first kind. And what do the textbooks do with the second kind? They throw it away. By hand. There is no equation that forbids the advanced solutions. There is only a physicist somewhere in every derivation, quietly crossing them out because they offend our sense of order. The rule that causes precede effects enters the physics not as a discovery but as an editorial decision. A few physicists found that unbearable enough to do something about it. In 1945, John Wheeler and a young Richard Feynman built an entire theory of electromagnetism, absorber theory they called it, that refused to throw the backward waves away. In their picture, both solutions are real, and the one-way appearance of radiation emerges from the circumstances of the universe as a whole, from the way matter is arranged to absorb what is emitted. The theory did not conquer physics, but it planted a flag that matters for tonight. It was the first serious attempt to say that the direction of cause and effect might not be a fundamental ingredient of the world, but a consequence of the world's particular condition, not a law, a circumstance. You might wonder whether the quantum revolution changed any of this. It did not. Schrödinger's equation is as time-symmetric as Newton's mechanics ever was. And if you are tempted to reach for thermodynamics, for the famous second law, for entropy and its one-way climb, remember the boundary we drew a few minutes ago. The Austrian physicist Ludwig Boltzmann faced this exact challenge in the 1870s, when his colleague Joseph Loschmidt pointed out that you cannot squeeze one-way behavior out of two-way laws. Boltzmann's answer, one of the great ideas in the history of science, was statistical. Disorder does not have to increase. It is merely overwhelmingly likely to. But look at what that answer takes for granted. Likely to increase. In which direction? Toward the future. The statistical story presupposes that events are already laid out in an order, that there is a direction to be likely in. Entropy explains the current. It borrows the riverbed. The deeper question, where does the ordering of events come from, passes through Boltzmann's hands untouched. To be thorough, there is one small corner of physics where nature does treat the two directions of time differently at the microscopic level. Certain exotic particles, kaons, and their heavier cousins, the B-mesons, decay in ways that are not perfectly symmetric under time reversal. Experiments have confirmed this beyond doubt, but the effect is tiny. It appears only in rare processes most of the universe never engages in, and no one has ever found a way to build the everyday order of causes and effects out of it. It is a crack in the symmetry, not a foundation for the switch and the light. Then came Einstein, and for a while it looked like the search was finally over. General relativity, completed in 1915, seemed to give causal order a home at last, not in the laws of motion, but in the shape of space-time itself. Here is the picture, and it is one of the most beautiful in all of science. Nothing, no signal, no influence, no whisper of information can travel faster than light, roughly 300,000 kilometers every second, a speed so central to reality that the universe enforces it without a single recorded exception. Our particle accelerators push protons until they move within a few meters per second of that limit, pouring in energy that shows up as everything except additional speed. And because influence has a speed limit, every event in the universe carries a kind of geometry around it. Picture any single moment, a match struck, a star collapsing, a word spoken. From that event spreading outward at the speed of light, there is a cone of places and times that the event can possibly touch, its future. And converging onto that event there is a mirror image cone of all the places and times that could possibly have touched it, its past. Physicists call them light cones, and they are the universe's actual bookkeeping of cause and effect. An event can influence only what lies inside its future cone. It can be influenced only by what lies inside its past cone. Everything outside both cones is elsewhere, unreachable, untouchable, causally disconnected. This structure is not decoration. In the 1970s, results proved by Stephen Hawking and by the philosopher of physics David Malamud showed something astonishing. If you know the complete web of which events can influence which other events, nothing else, no distances, no clocks, just the raw yes or no of possible influence, you have already fixed the geometry of space-time almost completely, everything except an overall scale. Read that again, because it inverts the way most of us picture reality. Causal order is not painted onto space-time. To a remarkable degree, causal order is space-time. The map of influence is the territory, and this is not abstract philosophy. The satellites that keep your phone's map honest must correct their clocks for the shape of those very cones, or your position would drift by kilometers within a day. So relativity found causality a magnificent home. But watch closely, because here is the sleight of hand that sets up everything else tonight. General relativity tells us that causal order and space-time geometry are two descriptions of the same underlying thing. It does not tell us where that thing comes from. Ask a relativist why the light cones exist, why events come pre-sorted into possible pasts and possible futures at all, and the honest answer is that the theory assumes it. In quantum field theory, the situation is even more explicit. Causality is written in as an axiom, a stone laid in the foundations by hand, with nothing underneath it. Physics did not derive the riverbed. It surveyed the riverbed gorgeously and called the survey an explanation. For 100 years, that was where the story rested. The most obeyed rule in the universe, located, mapped, and completely unexplained. And it might have rested there forever, if a small community of physicists had not started asking a question that sounds almost childish. If nobody can find where causal order comes from, what if it does not come from anywhere fundamental? What if, like so many things we once thought were bedrock, it is a surface? That question turns out to have a wall standing in front of it, a wall made of mathematics, and the wall has a name. Part 3. The Wall. Quantum mechanics is now 100 years old. The core of the theory was assembled in a furious burst between 1925 and 1926. Werner Heisenberg on his hay fever exile on the island of Helgoland, Erwin Schrödinger in the Alps over a Christmas holiday, and in the century since it has become the most successful physical theory human beings have ever produced. It has never failed an experimental test, not once, Every transistor in every device you own is a small monument to its accuracy, and yet, for that entire century, the theory has carried its strangeness with it like sealed luggage. Particles that take every path at once, measurements that seem to conjure definite outcomes from clouds of possibility, connections between distant particles that no signal could explain. The founders fought bitterly about what it all meant, and then, gradually, the field made a kind of peace that was really a truce. The equations work. Use the equations. The culture that grew up around this truce even has a famous motto, half joke and half confession: shut up and calculate. But there has always been a small community of physicists who could not make that peace, and they keep asking a question that sounds almost disrespectful. Why is quantum mechanics the way it is? Not how does it work. We know how it works, to a dozen decimal places. Why these rules? Why this particular blend of randomness and rigidity, this exact amount of strangeness and no more? When you ask why about a theory, you are really asking whether it is fundamental, whether you have hit bedrock, or whether you are standing on a floor with a basement underneath it. And here is the thing about flaws in the history of physics. Every single one of them so far has had a basement. We thought heat was a fundamental fluid. It turned out to be the jiggling of molecules one floor down. We thought solid matter was continuous and simple. It turned out to be mostly empty space, sparsely furnished with atoms. We thought the classical world of definite objects in definite places was the ground truth of reality. It turned out to be, and we will walk through this carefully later tonight, the smoothed-over surface of the quantum world beneath it. Classical physics emerges from quantum physics. That emergence is not a metaphor. It is measured, quantified, textbook science. So the question almost asks itself, if the classical world is the surface of the quantum world, is the quantum world the surface of something else? Physicists have even found a way to make that question precise, and it involves one of the most elegant experimental facts you have probably never heard of. Interference, the way possibilities overlap and combine, comes in mathematical grades. Classical physics has none of it, grade 0. Quantum mechanics has exactly grade 2. Possibilities interfere in pairs, and the famous patterns of quantum experiments are all built from pairwise combinations. But the mathematics allows, in principle, theories of grade 3, grade 4, and beyond. Theories in which triplets of possibilities conspire together in ways quantum mechanics cannot describe. In the 1990s, the physicist Raphael Sorkin turned this into a ladder of conceivable theories, and in 2010, a team of experimenters led by Urbasi Sinha tested it directly, using a 3-slit version of the classic interference experiment. If nature had any grade 3 interference, a specific signature would appear. They measured with exquisite care, and the signature was absent, bounded to less than 1 part in 100 of the ordinary interference. Nature, as far as we can measure, stops precisely at grade 2, which makes the ladder even more haunting. Why does the universe climb exactly 2 rungs and then stop? One tantalizing possibility is that it does not stop, that the higher rungs are real, 1 floor down, and something wears them away before we can see them. Maybe there is a richer theory in the basement, with more kinds of interference and stranger structure, and some process, some universal fading, some averaging, grinds its exotic features down until only the quantum rules survive at our floor. The idea has a name that will run through the rest of tonight like a thread: hyperdecoherence. Hold on to the shape of the word. Decoherence, as we will see, is the established, measured process by which quantum physics fades into classical physics. Hyperdecoherence would be the same kind of fading, one level deeper, a post-quantum world fading into quantum mechanics. Through the 2000s and 2010s, theorists actually built candidate basements to test the idea on paper. There were quartic theories, with denser mathematical machinery than the quantum rules allow. There were exotic constructions called density cubes. The attempts were ingenious, and they kept stumbling. The toy theories would not decay gracefully into quantum mechanics, or broke something essential on the way down. Still, these were stumbles, not verdicts. The dream stayed alive. Find the right basement, and quantum mechanics stops being a brute fact and becomes a consequence. Then, in 2018, the dream hit a wall. 2 young theorists, Tsiran Lee and John Selby, published a paper in the Proceedings of the Royal Society, one of the oldest scientific venues on Earth, with a title that reads like a locked gate: a no-go theorem for theories that decohere to quantum mechanics. A no-go theorem is exactly what it sounds like. Mathematics that does not merely fail to find something, but proves it cannot be found. And what Lee and Selby proved was, on its face, devastating to everything we have been building toward tonight. They showed that under a short list of assumptions, no deeper theory can hyperdecohere into quantum mechanics. None. Not the quartic theories, not the density cubes, not any post-quantum basement anyone might dream up in the future. The proof did not check candidates one by one. It closed the whole category. Every no-go theorem stands on its assumptions, so let us look at the two that matter, because they will decide the fate of everything that follows. The first assumption is called causality, and in this technical setting it means something crisp. In any respectable theory, information cannot flow toward the past. What happens now cannot signal backward. The second is called purification, and while the mathematics is intricate, the spirit is simple. Every messy, partial, uncertain process in a respectable theory must be explainable as a clean, complete process seen from a limited point of view. And crucially, that clean completion must be essentially unique. One messy view, one clean underlying story. Quantum mechanics itself obeys both principles beautifully, and both feel less like assumptions than like table manners for physical theories. Of course, a sensible theory forbids signaling to the past. Of course, a sensible theory has unique clean descriptions under its messy ones. Lee and Selby asked only that the basement be as sensible as the house, and from just that much sensibleness, the wall followed. Quantum mechanics cannot be anyone's surface. The bottom floor is the bottom floor. You can feel the psychological weight of a result like that. The question that had quietly motivated a century of the field's most curious minds, why these rules, was now answered, and the answer was, stop asking. For 7 years, that was, for most practical purposes, the end of the conversation. The theorem gathered citations the way settled things do. Researchers moved on. If you proposed a deeper origin for quantum theory at a conference, someone in the second row would clear their throat and say the names Lee and Selby, and that would be that. Physics kept a wall where a door might have been, and the wall was made of exactly the material walls should be made of: rigor. But there is something about no-go theorems that the history of physics keeps trying to teach us, and the lesson is worth taking slowly because it is about to become the hinge of the entire night. A theorem is a machine. Assumptions in, conclusion out. The conclusion is only as unbreakable as the assumptions are unavoidable, and assumptions that feel unavoidable are the most dangerous kind because nobody rechecks them. They sit in proofs the way load-bearing walls sit in old houses, except that sometimes, when an engineer finally looks closely, a wall everyone treated as load-bearing turns out to be holding up nothing at all. It has happened before. Famous impossibility arguments about hidden variables in quantum mechanics stood for decades before John Bell showed that one of their assumptions was quietly doing all the work. The wall was real. The wall was rigorous. The question was whether the wall was standing on ground that had to be there. Which brings us to the autumn of 2025, and to two physicists who did what almost nobody bothers to do with a famous impossibility result. They read it again, slowly, with a screwdriver in hand. Part 4. The paper that picked the lock. In the first week of November, 2025, a paper appeared on the Archive, the open shelf where physicists post their work for the world to read before the journals weigh in. It carried one of those titles that only a specialist would slow down for: Decoherence to Quantum Theory from a Causally Indefinite Post-Quantum Theory. No exclamation points, no press release, just 11 words that, unpacked, amount to a direct challenge to the wall we just spent an entire chapter building. The authors were James Hefford and Matt Wilson, two theoretical physicists working in quantum foundations, that small, stubborn corner of the field that never signed the truce, the community that kept asking why, long after asking why went out of fashion. 5 months later, on the 14th of April 2026, the paper finished its journey through peer review and was published in Physical Review A, one of the standard journals of atomic physics and quantum information, a venue where referees are paid in patience and check the mathematics line by line. That publication date matters. It means this is not a blog post, not a preprint floating in limbo, not a speculative manifesto. It is a result that professional skeptics tried to break and could not. Whatever we make of it tonight, it has earned the right to be taken seriously. So what does it actually claim? Let me state it with the care it deserves, because both halves of the sentence carry weight. Hefford and Wilson constructed an explicit mathematical process, a map, in the language of the field, that takes as its input a deeper theory in which causal order does not exist, and produces as its output ordinary quantum mechanics, causal order included. The deeper theory is not vague. It is a known, well-studied mathematical framework, and we will spend the next chapter walking around inside it. The process is not vague either. It satisfies the formal defining conditions of hyperdecoherence, the same kind of fading by averaging that turns quantum physics into classical physics, run one floor lower. Input, a world with no before and no after. Output, our world, with its switches and its lights and its rigid rule about which comes first. That is the claim. Quantum mechanics derived. Causality manufactured. But wait, the wall, the theorem. Lee and Selby proved this could not be done, and their proof has not been retracted and nobody has found an error in it. Both things are true, and the resolution is the most instructive part of the whole story. Remember that a theorem is a machine. Assumptions in, conclusion out. Hefford and Wilson did not attack the machine. They walked around to the back of it and examined the two assumptions feeding it. The two principles that seemed like mere table manners. No signalling toward the past. Unique clean completions of messy processes. And they asked a question of exquisite simplicity. Says who? Think about what those assumptions actually assert. They are properties of our world, the world upstairs, the finished world, and in our world they are magnificently true. No experiment has ever sent a message into the past. Quantum mechanics really does have the uniqueness property, but the basement is, by construction, not our world. It is the raw pre-emergence layer, the theory before causal order has condensed. Demanding that the basement obey no signalling to the past is demanding that a world without a past respect the past's privacy. The requirement is not wrong so much as unintelligible down there, like demanding that a box of unsorted photographs respect chronological order before anyone has built the album. And the uniqueness of purification, natural as it feels, is likewise a habit imported from the upper floor, not a logical necessity of every conceivable foundation. Hefford and Wilson realized that if you let the basement be what a basement would actually have to be, orderless, permissive, strange, then the two bolts holding the wall in place simply are not fastened to anything. Loosen them, and the no-go theorem still stands as mathematics. It just no longer stands in the way. The wall was real, the wall was rigorous, and the wall was, all along, resting on ground that did not have to be there. I want to pause on this, because it is the emotional centre of tonight, and it deserves more than a passing nod. For 7 years, anyone who wondered aloud whether quantum mechanics might come from somewhere could be shown a published theorem and told, with complete sincerity, it has been proven. There is no deeper flaw. Careers bent around that sentence. Graduate students chose other problems. An entire direction of human curiosity was posted with a sign that said closed, and the sign was believed, because it was written in mathematics, and mathematics does not lie. And mathematics did not lie. We simply misread what it said. It never said the door does not exist. It said, given these two assumptions, the door does not exist. Everything hung on 2 lines of fine print that a generation found too obvious to question. And this, if you look back honestly, is how nearly every basement in the history of physics was eventually found. Impossible, in physics, sometimes turns out to mean impossible, given assumptions nobody has rechecked lately. The most valuable discoveries are not always new particles or new galaxies. Sometimes they are old sentences, read slowly by someone who refuses to skim. Now, having given the paper its full weight, we owe it the discipline of stating what it is not. And here the authors themselves are our best allies, because their restraint in print is almost as remarkable as their result. The paper is an existence proof. It demonstrates that a hyperdecoherence process from a causally indefinite theory down to quantum mechanics exists as consistent mathematics. It does not claim that nature performs this process. It does not say when, or where, or how often, or by what dynamical mechanism. It contains, in its current form, no experimental prediction, no number you could go out and measure to test it. If you're keeping score at home, what has been shown is that the thing can be built. Whether the universe built it that way is a different question, and it remains wide open. And the authors go further, in a way that tells you something about the culture of this field at its best. In their own framing, the result supports two opposite readings, and they present both without choosing. Reading 1, the map is evidence of something real, a genuine hyperdecoherence process by which our causal, quantum world condensed out of a causally indefinite deeper reality. That is the exciting reading, the one that reframes a century of physics. Reading 2 is quieter and more skeptical. Perhaps the fact that such a map exists at all is a warning sign, a hint that the formal definition of hyperdecoherence is too permissive, that the axioms need tightening, particularly around the role that purity plays in them. On this reading, the paper's contribution is diagnostic. It has discovered a weakness in our definitions, not a basement under our world. 2 readings, 1 paper. The authors hold the door open and decline to tell you what is behind it, because they do not know, and they say so. Here is where our held question stands then, at the end of this chapter. 2 physicists have built and defended through peer review the very thing a famous theorem was believed to forbid, a mathematical origin for quantum physics, rooted in a world without cause and effect. What they have not done is prove that this origin is nature's actual biography. The discovery so far is the existence of the door, not what lies behind it. Whether that already changes everything, or changes nothing yet, is a judgment we will be equipped to make only at the very end of tonight, and I am going to hold you to the promise that we make it together, carefully, with all the caveats on the table. There is one more reason to trust the shape of this story, and it comes from the wall's own architects. Nothing about the new construction embarrasses Lee and Selby. Their theorem did exactly what good mathematics does. It took the field's unexamined common sense, made it explicit, and showed precisely what that common sense costs. In a real way, the 2018 wall is what made the 2026 door possible, because you cannot loosen a bolt until someone has written down, in public, exactly where the bolts are. This is how the field moves. The proof and the counter-construction are not enemies. They are 2 halves of one long sentence that took 8 years to finish. But before any of that, there is a walk we have to take. Because I have now said the phrase causally indefinite theory perhaps a dozen times, and I have let it stay a phrase, abstract, technical, safely at arm's length. That has to end. If quantum mechanics has a basement, you deserve to see it. Not the mathematics, the experience. What would it actually be like in a world where events have no order? Where things happen, but nothing happens first? The answer is one of the strangest guided tours this channel has ever attempted, and it begins with a box. Part 5. The World with No Wiring Diagram. The deeper theory in the Hefford and Wilson paper has a name that sounds like it came from a warehouse inventory, rather than a philosophy seminar, and I find that strangely reassuring. It is called the theory of quantum boxes, Q-boxes for short. No shimmering veils, no grand pronouncements, boxes, and the plainness of the name is a clue to how the framework thinks, because a Q-box is exactly what it sounds like, a container for a happening. Any quantum event that can possibly occur, 2 particles interacting, a system transforming, a signal being processed, can be wrapped up and treated as a box, with slots where influence can go in and slots where influence can come out. You do not need to know what is inside. The box is defined by what it does, what goes in, what comes out, and with what probabilities. Ordinary quantum mechanics uses boxes too. This way of thinking is standard in the parts of physics that gave us quantum computing. But in ordinary quantum mechanics, the boxes come pre-strung on a timeline, like beads on a wire. This box acts first. Its output feeds the next box's input. That box acts second, and its output feeds the third. The wiring diagram is the timeline. The timeline is the wiring diagram. Physicists literally draw these pictures. They are called circuit diagrams, and reading one is like reading a musical score, left to right, earlier to later, cause to effect. Every quantum experiment ever performed can be written as one of these ordered diagrams. The ordering is so automatic, so baked into the notation, that most physicists go entire careers without noticing they are assuming it. The theory of quantum boxes is what you get when a mathematician looks at that wire and asks the forbidden question, what if we remove it? Keep the boxes. Keep the quantum rules inside each box, but delete the requirement that the boxes be arranged in any order at all. What remains is what is called a higher order theory. Instead of studying states, or even operations on states, you study operations on operations, the ways boxes can plug into boxes. and when the framework combines two boxes, it uses the loosest lawful glue available, a rule with the wonderfully bureaucratic name of the non-signaling tensor product. The spirit of that rule is simple. Place two boxes side by side in such a way that neither one, on its own, can be used to send a message to the other. No master clock, no referee saying you first, just events, adjacent, with their possible connections left maximally open. If the phrase operations on operations feels slippery, here is a homelier way to hold it. Ordinary physics is like cooking. Ingredients go in, steps are applied in order, a dish comes out. Higher order physics is like being the editor of the cookbook. Your raw material is not the ingredients but the recipes themselves, and your job is deciding how recipes can be combined, nested, and rearranged. The Q-box theory is the fully permissive cookbook, the one that allows every combination of recipes that does not produce an outright contradiction, including combinations no ordinary kitchen with its ordinary clock could ever host. It sounds like an indulgence, but this ecosystem was not invented as a lark. It grew through the 2000s and 2010s out of respectable questions in quantum information science, questions about what computers could do if the order of their operations became a quantum resource like any other. The framework came first as a tool. Only later did it reveal itself as a candidate basement for the world. Now I need to make one distinction with real care, because the entire night turns on it. When the Q-box theory says the order of events is indefinite, it does not mean the order is unknown. Unknown order is boring, a sealed envelope with a definite letter inside. You do not know whether the letter says A came first or B came first, but one of them is true, and your ignorance is your problem, not the universe's. Causal indefiniteness is a different beast entirely. It means the question which came first has no answer. Not an answer we have not found, but no answer in the same way that the question of exactly where an electron is has no answer while it passes through both slits of the famous experiment. If you have travelled with quantum mechanics at all, you have met this move before. Quantities you assumed were always definite. Position, momentum, spin. Turning out to be definite only sometimes, only under certain conditions, only when the world is asked in a particular way. The Q-box theory takes that same move and aims it at the one thing even quantum mechanics never dared to blur. Not where things are, not how fast they move, when they are, or rather, in what order. I want to take you inside it. Set the mathematics down for a moment, close your eyes if they are not closed already, and come stand in the basement of the world. You are floating in a field of events. All around you, things are happening. A flash here, an interaction there, a transformation off to your left, if left still means anything, and it does not quite. Each event is complete in itself, crisp, real, like photographs developed in perfect clarity. Here, two particles meeting. There, a signal changing shape. Everything that occurs, occurring. But as you drift closer, you notice what is missing. There are no threads between them, no arrows, no line of dominoes. You reach out and pick two events, any two, the flash and the transformation, and you try to do the most natural thing a mind can do. You try to put them in order. First this one, you say, then that one, and the ordering will not attach. It slides off the events like water off glass. You try the reverse. First that one, then this one, and it slides off again. Not because you are wrong, because there is nothing for the ordering to grip. Asking which event came first is, down here, like asking which of two photographs in a shoebox happened first, while refusing to look at any album, any dates, any world outside the box. The photographs simply are. And the strangest part is that nothing feels broken. This is not chaos. Nothing is missing except the one thing you have never lived without. It is all still here. Every happening, every event, the complete inventory of a universe, resting, unarranged, like a story whose sentences are all written but have never been assigned a page. Come back up. Take a breath. What you just visited is what the phrase causally indefinite actually means, and I want to arm you immediately against the obvious objection, the one your common sense has been shouting for the last minute. Surely common sense says that place is just nonsense. Word salad wearing mathematics as a costume. Here is why it is not, and the reason is one of the most beautiful facts in this whole research program, one we will meet in the flesh in a later chapter. In frameworks like this, you can prove that every local observer, anyone sitting inside one of the boxes doing experiments in their own little laboratory sees perfectly ordinary quantum mechanics. Nothing strange ever happens inside a box. Each box from within has its own tidy little before and after. Signals come in, work gets done, signals go out. The strangeness lives entirely in the arrangement, in the fact that between the boxes, the universe declines to say whose before came before whose. Locally lawful, globally unarranged, which means the basement is not a rejection of quantum physics. It is quantum physics, with one assumption: the wire, the timeline, the page numbers, gently removed. So now you can see what the Hefford and Wilson claim really amounts to, in the flesh. They are saying start with that shoebox of unarranged photographs, apply one process, a specific mathematically defined fading, which we'll watch happen in detail later tonight. And when the fading is done, what remains is an album. Pages. Order. A world where every observer agrees that switches precede lights, that seeds precede trees, that the past is fixed and the future is open. Our whole causal existence on this picture is one special weathered corner of the Q-box world. The corner that survives the fading. Everything you have ever experienced, every sequence, every story, every life, unfolding inside the album that the fading built. And if a part of you is now leaning back and saying, that is a lovely picture, but emergence is doing an awful lot of unpaid work in it, good. Hold that suspicion. It is the correct instinct, and the next chapter exists to pay the debt. Because the word emergence is not a promissory note in physics. It is a documented phenomenon with a track record. There is at least one full-scale, measured, beyond all doubt example of an entire physics condensing out of a deeper one. A case where the surface world and the basement world have both been mapped in detail, along with the fading that connects them. You have been living inside that example all day. You're living inside it right now, actually. It is happening in the glass of water on your nightstand. So before we watch anyone manufacture a past, let us watch the universe do something it has verifiably done at least once before. Let us watch a world emerge. Part 6. The particles are not wet. Pour yourself a glass of water, or just picture one, cool and clear on the nightstand. I want to show you the single most important idea of the night, and it is sitting right there, doing something impossible. The water is liquid, it flows, it pours, it finds its level, holds a surface, soaks a sleeve, carries a ship if you give it enough company. Liquidity is as real as anything you will touch today, and here is the impossible part. If you go looking for the liquid in the water, piece by piece, you will never find it. A single water molecule, one oxygen atom, two hydrogens, a speck of matter so small that a glass holds roughly 10 to the 23rd of them, a number with more molecules in one swallow than there are stars in the observable universe, does not flow. It does not pour. It cannot be wet. Wetness is simply not a property a molecule can have, any more than a single brick can be a cathedral. The particles are not wet. Say it slowly because 6 words are going to carry the rest of tonight. The particles are not wet, and yet the water is. Come see it from the inside. You're shrinking now, drifting down through the surface of the glass. At first the world is everything you expect from water. Currents slide past you, pressure leans on you, a dropped speck of dust settles by in the slow-motion snowfall of sediment. Everything flows. Keep going. The currents begin to grain apart, the way a smooth photograph grains apart when you lean too close. Now the water is not a substance around you but a crowd. Molecules, endless molecules, tumbling and jostling, colliding billions of times each second, ricocheting like a stadium of frantic dancers who never touch for long. And somewhere on the way down, you cannot mark the exact floor where it happens, the wetness runs out. There is no smallest drop. There is no final, tiniest piece of liquid. There is only the crowd, dry as mathematics, bouncing in the dark. You hang there a moment, in the place where the thing you were swimming through has ceased to exist. Then you let go and rise, and the crowd blurs back into a substance. The graininess smooths into a current, and the wetness switches back on around you like a light. Nothing was added on the way up. No ingredient called liquidity was poured in at any floor. The flowing, soaking, shimmering fact of water is what 10 to the 23rd dry dancers look like from far enough away. Physicists call this emergence, and the first thing to understand is that it is not a consolation prize. Emergent does not mean fake. Ships float on emergent wetness. You can drown in it. Temperature is emergent too. A single molecule has no temperature at all, only speed, and yet a crowd of them has a temperature so precise we legislate it, brew with it, break fevers by it. Sound is emergent. One molecule cannot carry a whisper, but a corridor of air can carry a whole orchestra's pressure waves to your ear. In 1972, the physicist Philip Anderson gave this idea its banner in a famous essay titled More is Different. The observation that when you stack up enough simple things, the stack obeys laws of its own, laws that are real, reliable, and nowhere to be found in the pieces. An emergence can be sudden. Cool a cloud of steam past a threshold, and it does not become gradually somewhat liquid. It condenses, all at once, droplets appearing on the cold glass like a decision. Collective properties can switch on like circuit breakers. Keep that image of condensation close to night. We are going to need it at the exact moment this story reaches its strangest turn. And sometimes emergence does not merely repeat the laws of the pieces, it writes laws that look brand new. Cool certain metals toward absolute zero, and their electrical resistance does not shrink. It vanishes exactly, and a current set circling in a loop of such a superconductor will circle for years without fading, as though friction had been repealed. Cool liquid helium far enough, and it becomes a superfluid that climbs the walls of its container and slips through pores no ordinary liquid could enter. No single electron is a superconductor. No lone helium atom is a superfluid. These are collective behaviors so lawful, so sharp, that a physicist meeting them cold might swear a new fundamental force had been discovered, and yet each one is a crowd phenomenon, wetness by another name. Emergence, in other words, has range. It can produce properties as soft as dampness, and as spectacular as a current that never dies. So when someone proposes that a feature of reality as grand as cause and effect might be emergent, the correct response is not that is too big a thing to emerge. The track record says nothing is too big to emerge. The bigger question is whether anyone can show the machinery. Now, all of that might sound like a pleasant detour through a physics classroom, so let me bring it back to the edge of our actual mystery. Everything we have discussed, wetness, warmth, sound, is a case of classical properties emerging from smaller classical pieces. The question that matters for tonight is whether an entire physics can emerge from a different physics, whether the deepest rules themselves can be a surface. And the answer, established beyond argument over the last half-century, is yes. It has happened at least once, and we caught it in the act. We have spent whole nights on this channel inside that story, so I will keep the retelling brief. But the shape of it is the load-bearing precedent for everything the new paper claims. The classical world, this solid, definite world where cups sit in exactly one place and moons exist whether or not anyone looks, emerges from the quantum world through a measured, quantified process called decoherence. The discovery of that emergence has its own quiet human story, worth 30 seconds of our night. When the German physicist H. Dieter Zeh first proposed, in 1970, that the classical world might be produced by quantum systems leaking information into their surroundings, the idea was so unfashionable that he struggled to publish it, and was warned it could harm his career. The truce culture, again, defending its silence. It took the 1980s and the work of Wojciech Zurek to turn the idea into calculable, testable physics, complete with a name for the environment's role in selecting which states survive. Today, decoherence is measured routinely in laboratories, and engineers who build quantum computers spend their careers fighting it, because it is the very process that keeps erasing their fragile machines back into ordinary classical objects. An idea that began as one stubborn man's unpublishable heresy is now an industrial nuisance. Remember that arc when you weigh tonight's paper. Here is the shape, compressed. Quantum systems can hold superpositions, genuine combinations of ways of being that classical objects never display. Left in perfect isolation, a superposition persists. But nothing macroscopic is ever isolated. Air molecules collide with it. Photons scatter off it. Every collision carries away a little imprint of the object's state, like a crowd of paparazzi each stealing a partial photograph. And as those imprints spread into the environment, the delicate quantum combination is shredded, not by any mysterious collapse, but by sheer, relentless information leakage. What survives the shredding is the narrow menu of stable, definite-looking states, the ones we call classical, and the speed of it beggars belief. For a dust grain floating in air, A superposition of two positions, a hair's width apart, is destroyed in around 10 to the minus 31 seconds. A fraction of a second so small that comparing it to the blink of an eye is pointless. The blink might as well be the age of the universe. Even if you exiled that grain to the emptiest gulf between galaxies, the faint surviving glow of the Big Bang itself, a few relic photons per cubic centimetre, would decohere it in about a second. There is nowhere in this universe to hide from the environment. That is why you have never seen the quantum world with your naked eyes, and never will. Classicality is what quantum physics looks like after its exotic structure has been averaged away by 10 to the 23rd tiny witnesses. Honesty requires one asterisk, and I will give it exactly one sentence. Decoherence explains beautifully why we never observe quantum strangeness at breakfast. But the question of why any single definite outcome occurs at all, the famous measurement problem, survives decoherence, and we have wrestled with it on other nights. Keep it filed, because any deeper theory will inherit a cousin of the same wrinkle. Asterisk delivered. Look at the architecture we have uncovered, because it is the whole argument of the new paper in miniature. Downstairs, a stranger theory, with richer structure, superpositions, interference, possibilities held in combination. Upstairs, a tamer theory, definite, solid, reliable. Connecting them, a process of fading by averaging in which the exotic structure leaks away into what is not being tracked, and the tame world condenses out of the strange one. That is decoherence. Now run the pattern one floor lower. Downstairs, a stranger theory still, the Q-box world, with its richest structure of all, events free of any arrangement. Upstairs, are quantum mechanics, tamer, ordered, causal. Connecting them, if Hefford and Wilson are pointing at something real, a process of fading by averaging, in which the orderlessness leaks away and time's album condenses out of the shoebox. The proposal is not that causality is an illusion. The proposal is that causality is the wetness of the world, absent in every fundamental piece, undeniable in the whole, and manufactured lawfully by the crowd. The particles are not wet, and yet the ocean is. If that pattern runs one level deeper than we thought, if before and after itself is the moisture that condenses when an orderless world is viewed from inside, then the question we have been circling all night stops being philosophy and becomes engineering. Show me the mechanism. And before we walk through the mechanism's gears, we have earned a short pause to gather every piece we're holding onto one table. There are more pieces than you may realize, and laid side by side, they make a shape. Part 7. Putting the pieces together. Let us step back for a few minutes and put the pieces on the table, because we have gathered more of them than you might realize, and laid side by side they make a shape. If you have been drifting, this is a good place to rejoin the road. If you have been with me the whole way, think of this as turning around on the trail to see how far up the mountain we have come. Piece 1. The most obeyed rule in your life, causes before effects, the switch before the light, appears nowhere in the fundamental laws of physics. Newton, Maxwell, Schrödinger, Einstein. Every one of their equations runs as happily backward as forward. The rule that governs everything is missing from the rulebook. Piece 2. The century-long search for that rule ended in a magnificent relocation rather than an explanation. Relativity revealed that causal order and the geometry of space-time are nearly one and the same, the map of what can influence what is the shape of the universe itself. But nothing in physics says where that map comes from. It is assumed. In the quantum theory of fields, it is written in by hand, an axiom resting on nothing. Piece 3. When physicists asked whether quantum mechanics, and with it, causal order, might be the surface of something deeper, they ran into a wall. A theorem, published in 2018, proving from two common-sense assumptions that no deeper theory could ever fade into quantum mechanics. For 7 years, the question was filed under impossible, and the field mostly stopped asking. Piece 4. This spring the wall opened. Two theorists, Hefford and Wilson, showed that its two load-bearing assumptions, no signalling toward the past, and unique clean completions of messy processes, are habits of our upstairs world, not necessities of a basement. Relax them, and a door appears exactly where the wall stood. Through peer review, in print, in Physical Review A, this April. Piece 5. The basement on the far side of that door is not vague mysticism, but a specific mathematical world. The theory of quantum boxes. Events, real and lawful, each perfectly quantum on the inside. with the timeline connecting them deleted. A shoebox of developed photographs and no album. Order not unknown but undefined, and piece 6. The pattern the paper relies on, a strange rich theory fading by averaging into a tamer one, is not a hopeful invention. It is the documented biography of the world you're lying in right now. Classical reality condenses out of quantum reality through decoherence, at speeds, and with a thoroughness we have measured. Emergence has range, from dampness to superconductivity. The particles are not wet, and the water carries ships, 6 pieces, and notice the shape they make when you slide them together. A missing rule, a map with no maker, a wall that turned out to be standing on air, a basement with the right kind of strangeness, a precedent proving that exactly this kind of condensation happens in nature. If you are assembling a case that causal order, the before and after of the universe, is manufactured rather than fundamental, this is very nearly the case you would assemble. It is coherent, it is disciplined, each piece is peer-reviewed. Before we go on, rest inside that shape for a moment, because it deserves a slow breath. Somewhere near you, right now, something is happening in sequence. A clock is handing 1 second to the next. A house is cooling in the dark, warmth leaving the walls in strict order, earlier to later, never the reverse. If you are outside somewhere tonight, or near a window, the light arriving from the stars is keeping the same discipline. Each photon launched long ago, travelling first through 1 light year and then the next, arriving at your eye at the end of its sequence and never at the beginning. The whole visible universe is an orchestra of before and after, playing in perfect time, and it has never once missed a beat in 13.8 billion years of performance. That reliability is real, and nothing we learn tonight will take it from you. The question on the table is only whether the conductor is standing at the front of the orchestra, or whether the musicians, in numbers too large to imagine, are generating the appearance of a conductor by the sheer lawfulness of the crowd. Either way, the music plays. Either way, you can close your eyes inside it. But you should also notice what kind of pieces they all are. Every one of them is made of theory, equations, theorems, frameworks, precedents. Paper, in the end, however rigorous. And physics has a long memory of beautiful paper. The history of science is a museum of coherent, disciplined, elegant cases that turned out to describe nothing because the universe declined to cooperate. The luminiferous ether was a beautiful case. Light is a wave. Waves need a medium. Therefore a medium fills all of space, and every step was reasonable, and the ether does not exist. The crystal spheres of ancient astronomy carried the planets flawlessly for centuries of prediction, and there are no spheres. Elegance is a compass, not a verdict. The one question that separates a research program from a bedtime story is brutally simple. Has anything real ever been observed? Not derived, observed. Has any laboratory, anywhere on this planet, ever actually caught causal order, doing what this entire story requires it to be able to do, going soft, going indefinite, refusing to say which event came first? It is the right question to ask at the midpoint of our night, and I have been saving the answer for exactly this moment, because it is the moment the story stops being made of paper. The answer is yes. It has been yes for about a decade. In a small optics laboratory in Vienna in 2015, a team of physicists built a machine in which 2 operations were performed on a single particle of light, and the question of which operation happened first was given, by every measurement that could be made, no answer at all. Not hidden, not unknown, undefined, certified statistically in black and white on a printout. The machine fits on a tabletop. The result has been repeated, sharpened, and extended on 2 continents. Causal order has been suspended on purpose by human beings using mirrors. I want to be precise, even here, about what that laboratory did and did not do, because precision is the price of being trusted with a story this strange. The machine in Vienna did not open a portal to the Q-box basement. It did not violate causality, and no message was sent to anyone's past. What it did was something quieter and, in its own way, more profound. It took the one property of reality that even quantum mechanics had always left untouched, the order in which things happen, and demonstrated that this property too can be placed into the strange, both at once condition that quantum theory reserves for its most fundamental quantities. Order joined the list: position, momentum, energy, spin, and now sequence itself. Once something is on that list, it is no longer bedrock. It is negotiable, under the right conditions, and everything else in tonight's story flows from that single demotion. Whatever you thought you knew about how strange this night was going to get, adjust it now. Let me take you to the bench where it happened. Part 8. The bench where order dissolved. The road to that Viennese tabletop begins, fittingly, with a question about gravity. In the mid-2000s, the theoretical physicist Lucian Hardy was worrying at the oldest open wound in physics, the incompatibility of quantum mechanics and general relativity, when he noticed something about the two theories that nobody had put quite so plainly before. Quantum theory, he observed, has dynamic states on a fixed causal structure. Things evolve unpredictably, but the stage of before and after is bolted down. General relativity is the opposite. Its causal structure is dynamic. Space-time bends and flexes, but its events are definite, classical, sure of themselves. Any theory that swallows both, Hardy argued, must combine the two freedoms. It must have causal structure that is both dynamic and quantum, which is to say, indefinite. He began building a framework for physics without fixed causal scaffolding, which he called the causaloid, and in 2007 he pushed the logic to its natural provocation. A thought experiment he called the quantum gravity computer, a hypothetical machine that computes using operations whose order is not defined. At the time it read as philosophy with equations. It was actually a forecast. The forecast sharpened in 2012 when three physicists in Brussels and Vienna, Ognian Oreshkov, Fabio Costa, and Czaslaw Bruckner, published a framework that put indefinite causal order on rigorous mathematical footing. Their idea, known as the process matrix framework, starts from an almost diplomatic premise. Suppose there are two laboratories, run by two experimenters. Physicists like to call them Alice and Bob. Inside each laboratory, ordinary quantum mechanics holds perfectly. Each experimenter receives a system, acts on it, and sends it out, with a clean local before and after inside their own walls. The framework then asks, what is the most general way the universe could connect these laboratories? What correlations between them are possible? If we demand only that nothing contradictory ever happens, and pointedly decline to assume there is a global ordering that says whose operation came first? The answer astonished the field. The mathematics permits everything you would expect. Alice before Bob, Bob before Alice, mixtures of the two, and then it keeps going. There exist consistent processes, valid in every local respect, for which the question did Alice act before Bob has no answer at all. Locally lawful, globally unarranged, precisely the character of the basement we toured earlier, discovered independently, from nothing more than taking quantum mechanics seriously and refusing to smuggle in the timeline. Oreshkov, Costa and Bruckner went a step further, and the step will sound familiar if you know the history of quantum entanglement. They derived what are called causal inequalities, hard numerical limits that any world with a definite causal order, even a hidden, unknown one, must respect, in perfect analogy to the famous Bell inequalities that any world with pre-existing local properties must respect. And their exotic processes violate those limits on paper. Honesty compels a clear statement here, and it is an important one. No experiment has ever violated a causal inequality. The most exotic corners of the process matrix world remain, for now, mathematics. Whether nature ever performs them, anywhere, under any conditions, is unknown. Keep that limit in view all night. But there is a milder form of causal indefiniteness, certified, repeatable, sitting in the published record, and that is the one with the tabletop. It is called the quantum switch, proposed in 2013 by Giulio Ciribella, Giacomo Mauro Dariano, Paolo Perinotti, and Benoit Valiron. The design is almost mischievously simple. Take two operations, call them A and B, and a particle to apply them to. Add a control, a quantum coin. If the coin shows heads, the particle undergoes a first, then B. If the coin shows tails, B first, then A. So far, utterly ordinary. Now do the one thing quantum mechanics allows that no classical machine can copy. Place the coin in a superposition of heads and tails. The particle now traverses the two operations in a genuine quantum combination of both orders, not quickly alternating, not secretly one or the other, both orderings, held in the same suspended way an electron holds both slits. The order of events has become a quantum degree of freedom, one more property, like position or spin, that can be indefinite until the world is asked. In 2015, in a laboratory at the University of Vienna, a team led by Philip Walther, with Lorenzo Procopio as first author, built it. Come stand in the room while it runs. The laboratory is smaller than you were imagining. The apparatus rests on a steel optical table you could cover with a bedsheet, a low forest of mounts and mirrors and wave plates laid out like a tiny silver city. The lights are dimmed. There is a hum of electronics and the faint whir of cooling fans, and threaded invisibly through the middle of it all, a laser's light too faint and too controlled to see. Single photons are entering the maze one at a time. Each photon carries the control in its polarization, the orientation of its vibration serving as the quantum coin, and that coin routes it through loops of optical fiber toward the two operations, A and B, waiting in their mounts. Heads would mean A, then B. Tails would mean B, then A. The polarization has been prepared as both. Somewhere in the middle of this silver city, over and over, thousands of times per run, a particle of light is experiencing two histories of ordering at once, and nothing glows, nothing hums louder, nothing announces itself. The revolution is completely silent. At the far end, detectors click, counts accumulate, and a computer quietly assembles statistics that will bear the signature of the impossible. Interference between the two orderings themselves. When the team analyzes the data, the pattern is there, exactly as predicted. A pattern that neither ordering alone nor any mixture of definite orderings can produce. Stay in the room for the moment that matters. The run ends. Someone pulls the numbers up on a monitor, columns of counts, coincidence rates, error bars, and the pattern resolves out of the statistics the way a photograph resolves in a darkroom tray. There is no thunderclap in a moment like that. Laboratory revolutions arrive as a quiet line on a screen and a researcher leaning closer. But consider what the line is saying. For a century, every quantum experiment ever performed, every one, had taken the order of its own operations for granted, the one classical certainty nobody thought to question. This line on this screen is the first documented instance of human beings constructing a physical situation in which that certainty is measurably absent. The switch and the light, suspended, on a table, on purpose. 2 years later, the certification tightened. In 2017, Giulia Rubino and colleagues measured what is called a causal witness, a statistical instrument designed to detect with quantified confidence whether any definite order story could account for the data. None could. The result, published openly, amounts to a laboratory document stating that in this apparatus, the order of operations A and B was not merely unknown but indefinite. In 2018, a group at the University of Queensland in Brisbane, Kamudibakash Goswami and colleagues, in the laboratory of Andrew White, rebuilt the experiment with cleaner separation between the operations and confirmed it again. Since then, the effect has been extended. Switches superposing the order of more than 2 operations, demonstrations carried over kilometres of optical fibre between separated stations. This is no longer one miraculous afternoon in Vienna. It is a reproducible piece of experimental physics on multiple continents, a decade old. And it is not even a curiosity without consequences, because superposed order turns out to be useful, which in physics is the surest sign that something is real. In 2018, Daniel Ebler, Sina Salek and Giulio Chiribella proved a result that still sounds like a magic trick. Take 2 communication channels so noisy that each one alone destroys every message fed into it. 2 telephone lines so broken that pure static comes out regardless of what goes in. Chain them in either definite order and you still get static. A broken line followed by a broken line is a broken line. But send your message through the 2 channels in the quantum switch, in a superposition of both orders, and information gets through. The indefiniteness itself carries the signal, as if the 2 orderings interfere in just the way that lets a whisper survive the storm. Laboratory demonstrations followed. Related advantages have turned up in precision measurement and in small thermodynamic tasks, protocols for cooling and for charging that outperform any fixed-order strategy. Somewhere down the decades, there may be engineers who use superposed causal order the way today's engineers use superposed currents, and every one of their devices will trace its ancestry to that bedsheet-sized table in Vienna. If the arc of this feels familiar, it should. Quantum entanglement followed exactly this trajectory. Dismissed for decades as philosophy dressed in equations, then certified in laboratories against ever stricter statistical witnesses, then harnessed as a working resource. and eventually honoured with a Nobel Prize for the experimenters who forced the question. Indefinite causal order is walking the same road, a few decades behind. It has passed the philosophy stage. It has passed the first certifications. It has begun to be useful. History suggests we should be careful about betting against the rest of the road. So the scoreboard now reads, indefinite causal order, predicted by the mathematics, demanded by at least one road to quantum gravity, and certified in the laboratory, mildly but repeatedly for a decade. Which raises the question that the whole second half of our night hangs on. If order can go indefinite on a tabletop, with mirrors and patience, what happens in the one arena where the stage itself, space-time, the keeper of all the light cones, becomes quantum? What happens when it is not a photon's route that is superposed, but the geometry of the universe underneath the route? That is where gravity enters our story at last, and gravity, it turns out, has been waiting for this idea for 100 years. Part 9. Why gravity has been waiting for this. For very nearly a century, the finest minds in physics have been trying to officiate a wedding that keeps collapsing at the altar. On one side stands quantum mechanics, flawless in its domain, governing everything small. On the other stands general relativity, equally flawless, governing everything heavy. Stars, galaxies, the shape of the universe entire. Each theory has passed every test we have ever devised for it, and they cannot both be fundamentally right, because where their domains overlap, in the heart of a black hole, in the first instance after the Big Bang, anywhere something is simultaneously very small and very heavy, the two sets of equations forced together produce nonsense, infinities, probabilities that refuse to add up to one. A century of brilliance has been spent on this marriage, quantizing gravity this way and that, stringing the world out of vibrating loops of energy, weaving space from networks of abstract threads. Progress has been real, but the wedding has never been completed, and it is fair to say that no single failure in modern science has consumed more genius for longer. Tonight's ideas suggest a reason why, and the reason lives exactly where our whole story has been living, in the ordering of events. Follow the logic because each step is short and the destination is extraordinary. A quantum theory of gravity would be, by definition, a quantum theory of space-time itself. Whatever else it says, it must permit space-time, the actual geometry of the universe, to enter superpositions, just as electrons and photons and quantum coins do. Now recall what we learned in the first hour of our night. Causal order and space-time geometry are, by the deepest results of relativity, nearly the same thing. The map of what can influence what is the shape of the universe. Put those two facts side by side and the conclusion walks out on its own. A superposition of geometries is a superposition of influence maps. A superposition of influence maps is a superposition of causal orders. Any honest quantum theory of gravity must therefore contain situations in which the order of events is indefinite, not as an exotic garnish, but as a routine consequence of its own basic machinery. Remember the switch on the wall, the one we flipped in the first minute of tonight? In a superposed space-time, there are configurations in which no fact of the matter says whether the switch turned on the light or the light flipped the switch. The sentence sounds deranged, and it is also simply what the mathematics requires, and it is precisely the kind of sentence that has made quantum gravity so hard to make sense of for 100 years. This is not merely a channel's rhetorical flourish, it has been sharpened into physics. In 2019, 4 theorists, Magdalena Zich, Fabio Costa, Igor Pikovsky, and Czaslaw Bruckner, published a result with a title that gives away its ambition, Bell's theorem for temporal order. They designed a thought experiment in which a single large mass, a planet-sized bookkeeper of space-time, or in principle something far smaller and denser, is placed in a quantum superposition of 2 locations. Mass curves, space-time, mass slows clocks, that is ordinary tested relativity. The clocks on your navigation satellites run measurably differently from clocks on the ground for exactly this reason. So a mass in 2 places at once curves space-time in 2 ways at once, and 2 nearby events, 2 flashes, 2 operations, 2 anythings, can find their ordering superposed. In one branch of the situation, the first precedes the second. In the other branch, the second precedes the first. The authors proved that the correlations available in such a setup cannot be reproduced by any story in which events secretly possess a definite order. It is the gravitational quantum switch, the Vienna tabletop, rebuilt with space-time itself as the routing mechanism. No laboratory can yet perform it. The required combination of massiveness and quantum coherence is far beyond current technique, though tabletop programs testing whether gravity can entangle small masses are inching toward the foothills of the question. But as a matter of principle, the argument stands. Gravity plus quantum mechanics equals indefinite causal order. There is no escaping the basement by ignoring it. Those foothill experiments deserve a sentence of their own, because they are closer than most people realize. Proposals associated with the physicists Sugato Bose, Chiara Marletto, Vlatko Vedral, and their collaborators aim to place 2 micrometer-scale diamonds, each a crystal of billions of atoms, yet each held in a quantum superposition of positions, near enough that only gravity connects them, and then check whether the two become entangled. If gravity can entangle, gravity is quantum in at least the minimal sense, and the chain of reasoning that leads to superposed space-time, and with it, superposed causal order, acquires its first experimental anchor. The technical demands are brutal: vibration isolation, vacuum, coherence times that today's laboratories can only approach. But this is engineering hard, not principle impossible, and several groups are actively climbing toward it. The question of whether the universe can suspend before and after using gravity itself may be answered not by a telescope or a collider, but by 2 specks of diamond in a quiet basement, some year within the lifetimes of many people listening tonight. And now the reframing that this whole night has been building toward, and I will label it carefully, because it is the speculative summit of our story, the hypothesis rather than the finding. For a century we have assumed the problem of quantum gravity as a problem of combination. Here are 2 finished theories, both causally definite, both sure about before and after. Force them into one framework. What if that assumption is the whole problem? What if the marriage keeps failing because both partners are being asked to keep a property that neither actually owns at the fundamental level? On the emergence picture, the picture the Hefford and Wilson construction makes newly thinkable. The deepest layer of reality is something like the Q-box world. Quantum events, lawful and complete, with no causal arrangement at all. From that basement, 2 things condense, not one. Quantum mechanics as we know it, with its tidy sequencing of operations, condenses through hyperdecoherence, and space-time, with its light cones and its geometry, which remember, just is the causal order wearing a metric, condenses alongside it, 2 surfaces of the same fading. On this picture, quantum theory and general relativity are not rival descriptions of the bottom of the world that must be reconciled. They are sibling emergence, 2 patterns in the same condensation, no more in conflict than the wetness and the transparency of the same glass of water. The century of failed weddings would then be reread in one sentence. We were trying to marry 2 portraits when we should have been looking for the sitter. I should say, in fairness, that the field is genuinely divided about which end of this is up. There is a respected research program, causal set theory, that bets in precisely the opposite direction, taking discrete causal order as the one fundamental ingredient from which everything else, including space and time, must be built. The honest summary is that physics does not currently know whether causal order is the deepest thing in the universe or a surface phenomenon of something deeper still, and that this paper has, for the first time in years, made the second option a live mathematical possibility rather than a poetic one. Before we descend into the machinery of how a past actually gets manufactured, I want to sit for a moment with what this means at human scale, slowly, because it deserves slowness. Consider your own biography. You were born before you learned to walk. You learned to walk before you learned to read. Every regret you carry comes after the choice it regrets. Every hope you hold points at a future that has not arrived. Your entire sense of being a self, a single thread of experience, accumulating, remembering, growing older in one direction, is built out of before and after, the way a melody is built out of sequence. And what tonight's physics says, in its careful mathematical voice, is that this ordering is not guaranteed by the deepest level of reality. Pushed hard enough mass, enough coherence, enough strangeness, the universe declines to define it. The ordering of your life is not written into the bedrock. It is maintained, the way warmth is maintained, the way the shoreline is maintained, by scale, by circumstance, by the sheer stabilizing weight of 10 to the 23rd things all leaning the same way. I understand if that lands as unsettling, but hold it the way the science actually holds it, Nothing about you is in danger. The universe has kept your before and after intact through every second of your existence, without a single failure, and it will keep doing so for every second you have left. What has changed is only the nature of the promise. Your timeline is not held the way a law is held. It is held the way a ship is held by the sea, by something that has no shape of its own, and holds anyway, and has never once let the hull touch bottom. There is a kind of comfort in that if you let it settle. You're not standing on stone, you're floating, and you always have been, and you have never sunk. Which leaves the deepest question of the night still open on the table. If the basement has no order and our world has order, how exactly is the one manufactured from the other? What is the machine that builds a past? It is time to watch it run. Part 10. How to manufacture a past. How do you build a past? Not describe one, not assume one. Build one, out of raw material that contains no pastness at all. This is the question the Hefford and Wilson paper actually answers, and I want to walk you through the answer as carefully as popular language allows with 2 flags planted before we start. First flag, the paper is dense mathematics, and any walk through it in words, including this one, including the commentary that has circulated around the paper, is a gloss, a faithful cartoon of a rigorous machine. Second flag, familiar by now, what follows is an account of how a past can be built in principle, on paper. Whether nature built ours this way is the open question we carry to the end of the night. Flags planted. Here is the machine. Start with what the basement gives us, the Q-box world. Events, quantum happenings, each lawful on the inside, connected in the most permissive lawful way, with no ordering among them. Each box has slots, places where influence can arrive, places where influence can leave. In our upstairs world, those slots have fixed jobs. Inputs are fed by the past, outputs feed the future. In the basement, the slots have no such assignments, because there is no past to feed them and no future for them to feed. Influence down there is best pictured as a web rather than a river. Connections running every which way among the boxes, unpoliced, including patterns that, from our upstairs vantage, we would have to describe with a shudder as information flowing toward the past. In the basement, that phrase carries no scandal. Pastward is not a direction anyone has defined yet. The basement is not evil. It is merely unedited. Now comes the single move at the center of the paper, and it is a move you already understand, because you watched decoherence make it 2 chapters ago. When quantum physics fades into classical physics, the mechanism is a loss of tracking. The environment carries off information, those paparazzi photographs scattered into the air. And once that information is beyond recovery, the quantum structure that depended on it is gone from view, and the tame classical world is what remains. The fading is an averaging. You stop keeping books on some part of reality, and the strangeness that lived in those books closes its account. Hyperdecoherence, in the Hefford and Wilson construction, is the same move performed on the web of connections itself. In the gloss that has circulated, and it is a good gloss, the process averages over one side of the box's slots. Take every event in the basement and blur your bookkeeping of one face of it. Stop tracking the fine-grained detail of what arrives there, sum over the possibilities, let that side of every event dissolve into statistics. It is the mathematical equivalent of letting one side of every photograph fade to grey. And here is the wonder, the result that survived peer review. When the blurring is done consistently across the whole web, order condenses. The blurred side of the events hardens into what we call the past, the direction that feeds you, the direction you can no longer signal into, precisely because its details have been averaged beyond reach. The tracked side becomes the future, the direction your influence flows, the direction still open. The lawless web combs itself into a river, and the physics that remains on the surface, once the exotic pastward connections have faded below recoverability, is, exactly, not approximately, the standard quantum mechanics. The wave functions, the probabilities, the rigid rule that no laboratory anywhere can send a message backward. The entire familiar edifice, with causality now standing in it like a beam that was never installed, only revealed. The direction you cannot signal toward is the direction you stopped keeping records of. Before and after are not the stage the universe performs on. They are, on this construction, the ledger the universe keeps, and the ledger has a torn-off side. Let yourself see it happen. Go back down, one last time, to the field of unordered events, the shoebox world, the photographs adrift, everything happening and nothing happening first. It is just as you left it, complete, calm, unarranged. Now, the averaging begins. It does not begin anywhere in particular that would require a where and a when, and there are none. It simply begins everywhere, a soft blurring along one face of every event, like fog settling evenly across a landscape at night. Watch what the fog does. On the blurring side of each event, detail is going grey. Connections that ran into that face are losing their sharpness, their traceability, their ability to carry a signal, going from wires to weather. And as that side dims, something that was never there before quietly appears, a difference between the two faces. One side of every event is now closed, statistical, finished, feeding the event but no longer reachable from it. The other side is open, sharp, live. The difference is small, and it is everything. It is the first before and the first after that have ever existed here. The events have not moved. Nothing has moved. But a grain has run through the world, the way grain runs through wood, and suddenly the web has a direction the way wood has a direction. Cones of influence crystallize around each event, a cone of grey behind, a cone of light ahead. A speed limit condenses at their edges. Sequence appears. This event feeds that one, and that one feeds the next, and nothing feeds backward into the grey. What you're watching, condensing out of the fog like frost turning a window into a map, is a history. A universe that merely was is becoming a universe where things happen. First this, then that, the switch, then the light. And nowhere in the process was time poured in from outside. The pastness is made entirely of forgetting. There is something almost familiar in that picture, if you hold it against ordinary life. Think about how your own past works, practically speaking. You cannot visit it. You cannot send anything to it. What you have of it is records, memories, photographs, layers of sediment, light that left its source long ago. And every one of those records is a summary, a compression, a blur of an original that is no longer available in full. Archaeologists do not excavate the past. They excavate its statistics, shards and middens averaged by time into hints. Even your clearest memory is a reconstruction, redrawn each time you recall it. Our entire relationship with the past, in other words, already runs through exactly one channel, information that has been reduced from its original detail. The Hefford and Wilson construction takes that everyday epistemology and promotes it startlingly to metaphysics. The past is not a place that generates records as it recedes. The past, at the deepest level, is what being reduced to records means. We knew the past only through the blur. The proposal is that the past is the blur. Surface again, and let us bank what the machine has shown us, along with its honest limits. Notice, first, why the 2018 wall never touches this construction. The theorem forbade any basement that already respects the past from fading into quantum mechanics, but this basement respects nothing of the kind. It permits pastward signalling freely, in the only place such permission is meaningless enough to be safe, the region before a past exists. By the time the blurring has manufactured a past worth protecting, the protection is already in force. Upstairs, no signal travels backward, ever, and the theorem's other assumption, the uniqueness of clean completions, has likewise been left downstairs, where many different basement configurations can underlie one and the same upstairs process. That last point rewards one more moment of attention, because it carries a quiet philosophical sting. In quantum mechanics as we know it, every messy, partial process can be understood as a clean, complete one viewed with limited information, and that clean completion is essentially unique. One messy view, one underlying story. It is part of what makes our physics feel like it is describing a single definite world. In the basement, that uniqueness fails by design. A given piece of our tidy upstairs physics may sit above many different basement configurations, many distinct arrangements of the unordered web, all blurring down to the same quantum appearance. If this construction describes reality, then even a complete knowledge of our physics would underdetermine what the basement is actually doing, the way a photograph of fog underdetermines the individual droplets. The surface would be lawful, exact, and reticent, a world that keeps its accounts flawlessly while declining, as a matter of principle, to show its receipts. The no-go theorem is not broken. It is standing guard, perfectly intact, over a door that opens from the other side. Notice, second, what the machine does not do. It does not tell us why the blurring happens, or what dynamical process, what physics, performs the averaging. In the paper, the hyperdecoherence map is exhibited and its consistency is proven. It is not derived from some deeper engine, the way decoherence was eventually derived from ordinary quantum interactions with an environment. That gap is real, the critics have gathered around it, and it is the first thing we must weigh in the next chapter. Because every key that opens a locked door has a price stamped somewhere on its shaft, and it is time to read this one's. Part 11. The Price of the Key. Every door that physics has ever opened in a place where a wall once stood has come with a price stamped on the key, and the mark of a mature mind, in science and everywhere else, is the willingness to read the price tag out loud before celebrating. So let us read this one, item by item, because the honest ledger of this discovery is what separates tonight's story from the breathless headlines that will inevitably grow around it. Item 1 on the receipt. The basement is allowed to signal toward the past. We softened this earlier by noting that pastward means nothing before a past exists, and that softening is legitimate, but do not let it fully anesthetize you. A framework in which influence can run in what will become the backward direction is a framework that has given up, at its deepest level, one of the most cherished prohibitions in physics. The construction quarantines the strangeness downstairs and proves the quarantine holds. Nothing pastward ever leaks into the emerged upstairs world. But a skeptic is entitled to squint and say, "You have explained the sanctity of the past by assuming a level of reality where the past is not sacred." That is not a contradiction. It is, however, a real philosophical expense, and it should be counted. Item 2. The uniqueness of purification is dropped. We just walked through what this means. Many possible basements beneath one surface, a world that declines to show its receipts. The expense here is subtle but real. Quantum mechanics' own version of this property is part of its tight, almost crystalline mathematical structure, one of the features that makes the theory feel inevitable rather than arbitrary. The basement, lacking it, is a floppier, more permissive place. Floppiness downstairs is precisely what made the door possible. But a theory that permits more is a theory that explains less, unless something else picks up the slack. Whether the Q-box framework has the right amount of floppiness, or too much, is exactly the sort of question the field will now spend years arguing about and should. Which brings us to the criticisms, because the reception of this paper among physicists has not been uncritical applause, and you deserve to hear the strongest objections in their strongest form. The most pointed public commentary, from a prominent physicist and science commentator with a long record of skepticism toward quantum hype, graded the paper, with affection, it should be said, at 5 out of 10 on her personal skepticism meter, and delivered 2 objections that have stuck. The first, the construction feeds in too much of what it claims to derive. The Q-box world is not some alien substrate discovered on a beach. It is built from quantum ingredients, quantum events, quantum probabilities, the machinery of quantum information theory with the ordering removed. Deriving quantum mechanics from a framework already made of quantum parts, the objection runs, is, in the commentary's memorable phrasing, a bit like baking bread and then announcing you have discovered flour. It is a fair hit, and it lands. The paper does not conjure quantum theory from nothing. It conjures quantum theory's causal architecture from a quantum theory without one. The discovery is about the origin of order, not the origin of quantumness itself, and any headline suggesting otherwise, including, some would say, a headline like tonight's title, needs that asterisk attached. The second objection cuts at the mechanism itself. The averaging step, the blurring that manufactures the past, is imposed rather than derived. Hefford and Wilson exhibit the hyperdecoherence map and prove it consistent. They do not show what physical process performs it, or why the universe should perform it at all, rather than remain happily unordered. In the critical gloss, the authors needed a past for consistency, so they declared one. Defenders of the paper have a genuine response here, and it is historical. Decoherence itself began exactly this way. Zay's original insight was an imposed coarse graining, a recognition that if you stop tracking the environment, classicality appears, and it took a further decade and more before the dynamics doing the tracking loss were worked out in detail and confirmed by measurement. First the map, then the mechanism, is how this kind of physics has matured before. That defense is fair too, but a defense by precedent is a promissory note, not a payment, and the note comes due. Until someone shows what does the blurring, The construction remains a possibility proof about reality rather than a description of it. There is a third item on the receipt, less quotable than bread and flour but arguably the most important for working scientists. The paper, in its current form, predicts nothing measurable. It draws no line on any graph that an experiment could cross. This does not make it unscientific. Existence proofs and frameworks have always been part of physics' toolkit, and the process matrix framework itself made no predictions in 2012, yet it seeded a decade of laboratory work. But it does define the debt. For this construction to graduate from mathematics to physics, someone must find its fingerprints, a residue of the basement that survives the blurring, some faint statistical deviation in a regime where the averaging is incomplete, near black holes perhaps, or in the early universe, or in some future tabletop system pushed to the edge of gravitational coherence. Until a fingerprint is named, the honest classification of this work is a rigorous possibility priced and published awaiting its first bill from reality, and yet, listen to what even the sharpest criticism concedes, because it is the quiet heart of this chapter. 5 out of 10 from that particular grader is not a failing mark. It came wrapped in a sentence acknowledging that the paper does the one thing the critic has spent a decade demanding of the field. It tries. It attempts to explain quantum strangeness rather than glorify it, to put something underneath the weirdness instead of naming the weirdness and marketing it. The same commentary that mocked the bread and the flour also called the work a step in the right direction, and welcomed it, and meant it. In a field where, by the critic's own account, too many physicists have made peace with mystery as a brand, a paper that swings a hammer at the bottom floor and connects, even at an angle, is news precisely because of who is applauding through gritted teeth. So here is the fully priced verdict, and notice how much stronger it is for the pricing. The authors themselves offer 2 readings and refuse to choose, perhaps a genuine mechanism, perhaps a flaw in the axioms of hyperdecoherence, a sign that the formal rules, especially around purity, were too loose and let something through that should not count. The critics add, too many quantum ingredients assumed, the crucial step declared rather than derived. All of it is true at once, and none of it closes the door. What stands, when every discount is applied, is this irreducible fact. For 7 years the field believed a theorem forbade any theory from fading into quantum mechanics, and that belief is now, demonstrably, wrong as a general claim. The door is real. It is smaller than the headlines will say. It opens onto a corridor whose length nobody knows. But it is open, in the permanent record, with referees' initials on it, and physics has been changed by smaller doors than this. You can even see from here what the corridor's first few meters would look like, the research program this paper makes possible, which did not exist as a fundable idea 2 years ago. Someone will try to derive the blurring, to find a dynamics, an interaction, an engine that performs the averaging the way environmental scattering performs decoherence. Someone will try to tighten the axioms, to discover whether a more honest definition of hyperdecoherence closes the door again, which would itself be a discovery about why quantum theory is special. Someone will try to shrink the quantum ingredients, to build the door's twin out of a basement with less quantumness fed in, chasing the origin not just of order but of the quantum rules themselves. And someone, give it a decade, will try to name a fingerprint and propose the first experiment. Papers like this one are judged, in the end, not by their own claims, but by the quality of the work they provoke. The provoking has already begun. This is what real progress looks like, by the way, and it is worth saying so plainly, because we live in a time when science reaches most of us pre-inflated. Real progress is a door with a price tag, a proof with fine print, a 5 out of 10 that both sides consider a compliment. Distrust the stories that arrive without receipts, which is, as it happens, exactly where we must go next. Because around this small, priced, careful door, a fog of much larger and much cheaper claims is already gathering, and before we can give the final answer to tonight's question, we need to clear it. Part 12. The Fog Around the Door. If you spend any time at all near the shoreline where physics meets the public, you have seen the fog I am talking about. In the last few years alone, headlines have announced that particles experience negative time, that quantum experiments erase the past, that the future reaches backward to shape the present, that time itself does not exist, has been disproven, is officially an illusion, as though the universe had issued a press release. Tonight's paper will feed the same fog. It may already be doing so by the time you hear this. So before we deliver the answer this whole night has promised, let us take 3 quiet minutes to hand you the tool that cuts through all of it. Because the tool is simple, and once you have it, you will never read a quantum headline the same way again. Take the negative time story, which made the rounds not long ago after a genuinely interesting optics experiment in Toronto. Photons passing through a cloud of atoms produce timing measurements that, in one careful technical bookkeeping, could be assigned a negative value for how long the photon spent exciting the atoms. The researchers themselves cautioned patiently and repeatedly that this is an accounting of group delays, a subtle feature of how waves reshape as they pass through a medium, and not, in any sense, particles moving backward through time. The headlines printed the time travel version anyway. Or take the delayed choice quantum eraser, the poster child of past erasing claims for 2 decades. When you trace the actual mathematics, nothing about the past is ever touched. The experiment sorts its records into subsets after the fact, and the famous patterns appear only inside the sorted subsets. Post-selection, the statisticians call it. The same innocent operation as noticing that the average height of a crowd changes when you only count the basketball players. History sits serene and unedited throughout. In every case of this kind, and there is a new one every season, the same diagnosis applies. The mathematics is modest, and the story wrapped around the mathematics is wild, and the wildness is doing none of the predictive work. It is worth pausing on why this particular fog is so hard to disperse, because the reason is not simply that headline writers are careless. The reason is that quantum mechanics really is strange, permanently, irreducibly strange in ways this channel has spent many nights honouring, and genuine strangeness provides cover for counterfeit strangeness the way a real forest provides cover for plastic trees. A reader who has correctly absorbed that particles interfere with themselves, that entangled systems correlate across any distance, that the order of operations can be superposed on a laboratory bench, has no easy way to know that particles experience negative time is a different kind of claim than all of those, a claim the underlying mathematics does not make. The true weirdness calibrates people to accept the false weirdness, and the incentives all point one way. Mystery is clickable, mechanism is not. A story that flatters the reader with cosmic vertigo will always outrun a story that asks them to sit patiently with a derivation. None of this requires villains. It only requires a marketplace in which renaming pays as well as explaining, and it has for a long time now. Even working physicists have grown weary of it. There is a sharp and public complaint, running through the field's own commentariat, that some corner of the profession long ago stopped trying to dissolve quantum weirdness and started curating it, polishing the mystery, coining evocative names, feeding journalists stories that the underlying calculations do not say. The complaint has a bite to it precisely because the weirdness sells. Strangeness with a good name travels farther than a careful derivation ever will. You do not need to adjudicate how widespread the sin is to take the point of the diagnosis. And the tool it hands you is a single question, which I invite you to carry out of tonight and apply to every quantum claim you ever meet again. Does this idea explain the strangeness, or does it rename the strangeness? Renaming looks like, the particle knows, the universe decides, time is an illusion, vocabulary that gestures at the mystery and leaves it exactly where it was. Explaining looks like, here is a deeper structure, here is the mechanism by which the familiar thing arises from it, here is what it would take to prove us wrong. One is decoration, the other is architecture, and notice that the question works even when you cannot follow the mathematics yourself. You do not need to check the equations to check the shape of the claim. Ask what the idea would forbid, what it would cost, what could prove it wrong. Decoration forbids nothing, costs nothing, and can never be wrong. Architecture, as we saw in the last chapter, comes with a receipt. And now you can see why tonight's paper, whatever its final fate, sits on the honourable side of that line, and why even its harshest graders said so. The 5 out of 10, the bread and the flour, the objections we priced in the last chapter, every word of that criticism was aimed at how far the paper gets, not at which direction it walks. It walks toward explanation. It takes the single strangest fact of existence, that there is a before and an after, and instead of naming it, mystifying it, or shrugging it into a slogan, it proposes a structure underneath and a mechanism by which our world condenses out. That is the thing the sternest critics of quantum culture have spent years saying nobody attempts anymore. It was attempted. It survived review. The concession buried inside the harshest grade is the entire point. This is a real step, in the rarest direction physics knows how to walk. So the fog is cleared, the tool is in your pocket, and nothing now stands between us and the promise I made you in the first minutes of tonight. A question has been hanging over this entire journey, patient as the dark outside your window. What exactly did these physicists discover about the origin of quantum physics? And does it truly change everything? You have earned the plain answer. Here it is. Part 13. What was actually discovered. What was actually discovered is this. In April of 2026, in the pages of Physical Review A, two theoretical physicists, James Hefford and Matt Wilson, published a mathematically rigorous construction in which ordinary quantum mechanics, complete with its causal order, its inviolable past, its switches that always precede their lights, emerges from a deeper theory in which cause and effect do not exist. The deeper theory is the theory of quantum boxes, quantum events, lawful within themselves, connected with no ordering at all. The bridge between the two is hyperdecoherence, a fading by averaging, cousin to the measured process that dissolves quantum strangeness into classical solidity, in which the blurred side of every event hardens into a past, and the tracked side opens into a future. And the reason this is historic rather than merely clever is that for 7 years, a published no-go theorem had been read across the field as proof that no such construction could exist. It exists. The theorem was never wrong. Its assumptions were simply never mandatory. A possible origin for quantum physics, for the entire causal architecture of the world you live in, is now on the table, in the permanent record, peer-reviewed. That is the discovery. That is what the title of tonight's journey promised, and there it is, plainly stated. Now the second part of the plain answer, which you have earned by staying honest with me all night, what was not discovered. Nobody has proven that nature actually performs hyperdecoherence. Nobody has observed the Q-box basement, measured a fingerprint of it, or derived the dynamics that would do the blurring. The construction feeds in quantum ingredients. It explains the origin of quantum theory's causal order, not the origin of quantumness itself, and its crucial averaging step is exhibited, not explained. The authors themselves, with a restraint that does them honour, offer 2 readings and decline to choose. Perhaps this is the first sketch of a real mechanism. Perhaps it is a diagnosis that the axioms of hyperdecoherence need tightening. The sharpest public grade it received was 5 out of 10, wrapped in a genuine welcome. If you carry one sentence out of tonight, let it be this one, because it is the exact truth with all the receipts attached. Physicists have discovered a door where a wall was believed to stand, and no one yet knows what is behind it. So, does it change everything? You have all the pieces now, and you can feel how the 2 halves of the honest answer pull against each other. Nothing in your kitchen changes, no textbook equation changes, no experiment comes out differently tomorrow than it did last year, and anyone who tells you the past has become editable, or time has been overthrown is selling decoration, not architecture. You have the tool now, use it. And yet something real did change this spring, something that does not show up in kitchens or textbooks but shows up decisively in what it is now reasonable for a physicist to spend a life on. Judge it with me. Here is what a door like this changes, even if it never opens another inch. It changes the status of a question. For most of a century, why is quantum mechanics the way it is has been the kind of question that careers were quietly steered away from. Unanswerable in principle for some, answered by a theorem for others, and either way closed. It is now open. Not rhetorically open, mathematically open, with a published example proving the category of answer is non-empty. Every strange thing this channel has ever explored in the quantum world, the superpositions, the interference, the measurement mystery, and above all the rigid one-way grain of time, every one of them is transformed from a brute fact you must swallow into a phenomenon that might have an origin story. The weirdness becomes a surface. Surfaces can be explained. That is not a small shift in mood. It is the difference between living in a house with no basement and living in a house with a locked basement door. Nothing upstairs has changed, and everything about the house has. It changes, too, the shape of the oldest deadlock in physics. If causal order is emergent, then the century of failed weddings between quantum mechanics and gravity reads differently in hindsight, not as a failure of cleverness, but as a category error patiently repeated. 2 surface theories, each dressed in an emergent property, asked to merge as though that property were bedrock. The reframing does not solve quantum gravity. Let me say that with maximal clarity. Nothing published this year solves quantum gravity. But it relocates the problem, and relocations of great problems have historically been worth more than incremental attacks on them. The question stops being how do we quantize the stage and becomes what condensed into the stage, and there are now young physicists this year choosing thesis problems inside that question who would have been warned off it 2 years ago. Doors do their deepest work on the people who walk toward them. There is also the long game to consider, the pattern that history keeps insisting on, every single time physics has demoted something from fundamental to emergent. When heat was demoted from a fluid to the motion of molecules, the demotion looked purely philosophical, until it became thermodynamics, and thermodynamics became engines, and engines became the industrial world. When solid matter was demoted to mostly empty lattices of atoms, the demotion looked abstract, until understanding those lattices gave us semiconductors, and semiconductors gave us the device you're listening to me on. When classical reality itself was demoted to decohered quantum reality, the insight seemed destined for philosophy seminars, and today, engineers fight decoherence for a living inside quantum computers worth billions, machines that exist only because someone mapped the emergence in detail. Every demotion in the sequence eventually stopped being philosophy and started being infrastructure. If causal order joins the list, if the emergence of before and after ever graduates from possibility proof to mapped mechanism, it would be strange, given that unbroken record, for it to be the first emotion in history that changes nothing but our mood. What technology could possibly live in that direction, no one alive can say. The century that demoted heat could not have imagined a phone. But the record says, the basement always pays rent eventually, and it changes something quieter, which has nothing to do with careers or journals. It changes what you are permitted to think about the floor you're standing on. Remember, the particles are not wet. 6 words that have carried us all night. Water is made of things that cannot be wet, and the ocean carries ships. Warmth is made of motion that has no temperature, and it thaws you anyway. And now, in careful mathematics, if not yet in confirmed fact, before and after may be made of events that have no order, and your life unfolds in perfect sequence anyway. Causality, on this picture, is the wetness of the world, absent from every fundamental piece, undeniable in the whole, manufactured lawfully by something like forgetting, and no less real for being made. The switch, then the light. The universe's basement may hold no fact about which comes first, but you know which comes first. You have known it since before you could speak, and on the emergence picture that knowing is not an error the basement tolerates. It is the truth of the floor you actually live on, as real as the wetness that holds up ships. Emergence does not demote your world. It explains why your world holds. Let that settle for a moment, because it is the closing realization of our night, and it is gentler than it first appears. You, the pattern of memory and anticipation lying in the dark listening, are an emergent being, reading order into an orderless deep, and the reading works. That is the miracle hiding inside all the mathematics. Bread rises when you bake it. Children grow after you plant the garden never before. Apologies, spoken in time, still arrive in time. Whatever the basement is doing, whether it is a Q-box world with no wiring diagram, or something stranger still, or nothing but tidy bedrock all the way down, the floor above it has held every promise it has ever made to you. Every sunrise has followed its night. Every effect has honoured its cause. 13.8 billion years, and the album has never once shuffled its pages. If the order of the world turns out to be maintained rather than decreed, held the way the sea holds a ship by something with no shape of its own that has never yet let the hull touch bottom, then the right response is not vertigo. It is a kind of astonished gratitude. The universe did not have to hold. It holds. There is one more thing the demotion would explain, and I offer it as a parting gift rather than a proof, because it is the kind of thought that belongs to the edge of sleep. Have you ever wondered why the past feels the way it does? Sealed, finished, faintly grey, available only in summaries? Why memory is always a compression? Why no record is ever complete? Why the door behind you closes so absolutely that all the yearning in human history has never reopened it by a crack? We tell ourselves this is a limitation of memory, of records, of technology. But on the picture we have walked through tonight, it is not a limitation at all. It is the past's very substance. The sealed, summarized, irretrievable character of what came before is exactly what a past made of averaging would feel like from the inside. Finished because it is blurred, unreachable because unreachability is what it is made of. The ache of irreversibility, the one every human being carries, would be, quite literally, the texture of the mechanism that builds the world. I do not know if that is true. No one does. But it fits the night sky better than it has any right to, and some ideas earn a place in your thinking, not by being proven, but by being the first explanation you have ever heard for something you have felt your whole life. Where does it go from here? Slowly, honestly, the way real physics goes. Somewhere, a theorist is already trying to derive the blurring, to find the engine of hyperdecoherence, as a younger generation once found the engine of decoherence, and turned a heresy into a textbook chapter. Somewhere else, a skeptic is trying to tighten the axioms and close the door, which would be its own kind of discovery, a proof of what makes quantum theory special. In laboratories on 3 continents, the quantum switch grows sharper, longer, heavier, and in a handful of basements 2 specks of diamond are being coaxed year by year toward the experiment that will ask gravity, directly, whether it can suspend before and after. Perhaps the basement will show through someday at the edge of a black hole, or in the fossil light of the universe's first instance, some faint statistical grain in the pattern, the torn edge of the ledger, the fingerprint of the fog. Perhaps it never will, and the door opens onto bedrock after all. Either way, something has already changed for good, and it is the thing tonight's title named. What physicists just discovered about the origin of quantum physics changes everything, not because it answers the deepest question, but because it turns the deepest question back into physics. The wall is a door. The strangeness has a possible source. The oldest rule in your life, first this, then that, the switch, then the light, has for the first time in the history of science a candidate biography. And if you're still awake to hear this, let the last image of the night be the small one, not the cosmic one. Sometime tomorrow, without thinking, you will reach for a switch in a dark room. The light will come on, in that order, flawlessly, as always, whatever the basement knows or declines to know. Let it be, just this once, not invisible. One small, perfect performance of the deepest mystery we have, a universe that may have had to learn its order, keeping it anyway, every single time for you. Sleep well inside that reliability. It has never once failed you, and tonight, for the first time, you know how much may be working underneath to keep it that way.